Hi everybody, this is Miss Ellsworth, and what we're talking about this unit is energy. Anyways, there's two main types of energy, and that's all we're going to be talking about with this video. So just the types, the forms and changes, I don't know if we'll get to just yet. So that'll be for another video. Anyway, what is energy? And energy is actually the ability to do work. Okay, and so we'll get into that. So it's going to be closely related to work, meaning that it has the same exact unit. So that's kind of nice. You don't have to learn something new with that. So it's going to be measured in joules. So energy is the ability to do work. That's a great definition for it. Okay, so let's go and look at some of those. Okay, now the two different types of energy. The first one is the one about motion. That's why I have that going in motion there. So kinetic energy, and I'm going to go through and explain what all these are. So I just thought that I'd first of all introduce what they are. So the two types of energy are kinetic energy and potential energy. And I shouldn't have had potential energy moving much because it's not in motion. So let's go ahead and break these down. So the two types are kinetic and potential energy. And energy is the energy in motion. So if something is going to be moving, like this bike right here, if the motorcycle is going to be moving, then guess what? It's got kinetic energy. If it's not moving, then it has the potential to do to expend some energy, potential to do something. Then it's going to be strictly just potential energy. So potential energy is stored energy, and this one's in motion. This one is not in motion. So those are two big ways of always checking to see what they are. Now there are several types of potential energy, but there's only one kinetic energy. Okay, here's some stored energy, a car battery. Okay, so let's talk about kinetic energy specifically. Okay, is energy of motion. I've also seen this definition as being the energy in motion. Anyway, so there are some main things that affect kinetic energy. The faster that the object moves, the more kinetic energy it has. The greater the mass, the more kinetic energy it has. And you can abbreviate kinetic energy in your notes with just KE, capital K, capital E. Kinetic energy depends on both mass and velocity. In fact, that's the formula. It can be written a couple of different ways. KE equals mass times velocity squared, all divided by 2. Lots of students like to use this formula right here. I'm just going to go ahead and talk about what each variable means and what the units are in this bottom one. So kinetic energy, of course, is the ability to do energy, is in motion, so it's going to be measured in joules. Mass always must be put into kilograms. If you got grams, you got to go and change it into kilograms. And velocity is measured in meters per second. Okay. Let's look on to the next thing here. Oh, wait, I'm sorry. What has the greater effect of the kinetic energy, mass or velocity? So think about that for a second, but really the formula is quite telling. You're going to square the velocity. So if you increase the mass, it's going to increase the kinetic energy. If you increase the velocity, it's going to increase the kinetic energy. But hey, this one is squared, so of course it will matter more. It'll have a greater effect on the kinetic energy. There we go. Potential energy is next, and again, that is stored energy. Okay, now this could be stored chemically in fuel. That gasoline sitting in the tank of my car is definitely some potential energy to go and start moving, firing up and get going. Once it starts firing up and getting moving, then it's actually kinetic energy. But it's sitting there, it's stored energy, it's ready to go, isn't it? Okay, the nucleus of an atom. Okay, we could get quite a chain reaction going there to create some energy. Also foods. The foods give you the energy that you have also. A thing that you got to think about, that sometimes potential energy is not just this chemical potential energy here, but it's also other types of energy too, like a stretched rubber band. Okay, a stretched rubber band, if I'm going to stretch a rubber band pointing it at your face, you're going to want to move away because you know it's got the potential to do some damage. Okay, a watch is wound up in a clock. I don't know if too many of you guys know any wound up watches anymore, but those springs, when they're all tightened up, then they've got a lot of potential energy in them. Here's a picture of that rubber band. You know, if that's going to come towards your head, man, you're going to duck because you know it's got the potential to do some damage. Okay, a bow and arrow completely pulled back. Holding a brick high in the air. Okay, put it above your toe. You're going to know that could really, really hurt. Okay, otherwise you can hold that brick a little bit higher. You know, I mean, the potential energy, the higher it is, the more it's going to hurt, right? Okay, so there are 3 basic types that we will talk about. 3 basic types of potential energy. Now we keep on talking about types of energy. Next video will be about forms of energy. So if you go and look them up online, sometimes people write down types of energy as the forms of energy. So just make sure that you got this clear with what we're talking about here. I always learn that types of energy, our book also talks about types of energy being kinetic energy and also potential energy. But of potential energy, there's 3 types there too. Gravitational. So when you're holding something up above in the air, that's definitely got some gravitational potential energy because it's about how high it is. Elastic potential, you're seeing it right here. Okay, is stretching it out. It could possibly, go flying. Anyway, in chemical potential energy, we're talking about gasoline, food, those type of things are definitely chemical potential energy. Okay, so energy that is being stored to its, I've also heard of potential energy as the energy due to its position. Okay, if you're going to be, holding something up high, that's where its position is. Also how far something is stretched out, or else a spring is all shoved down, so it's going to, spring up, boing, and so the old-fashioned jack in the box, I don't know if they even have those anymore for kids, but bungee jumping, okay, that bungee has got a lot of potential energy, and the ones that start stretching out, then it's going to pull back. Potential energy. Now, gravitational potential energy, that's all about how high something is, okay, and how massive it is. If it's a pebble up here alone, that would hurt too, but not like this one would. Okay, so potential energy is energy that depends on the height of an object and also its mass. So if you go and look at this guy right here, he's going to dive off of a diving board. Okay, if you stand on a 3-meter diving board, you have 3 times the gravitational potential energy than you do if you're on a 1-meter board, because you're 3 times the height. Okay, so height matters for gravitational potential energy. Here's our formula for it. Mass times gravity times height all equals the gravitational potential energy. So I went and wrote it down here with the units again. All energy is ability to do work. So again, it's works unit, joules. Okay, mass again is measured in kilograms. Gravity is the acceleration due to gravity. Okay, so that's in meters per second. It's 9.8. You want to put that in your notes? It's 9.8 meters per second squared. Okay, and height is always measured in meters. Otherwise, things aren't going to cancel out the way that they need to. Okay, so let's talk about converting. Okay, so if you would look at a roller coaster, I'm going to move ahead to another one. Okay, hopefully this will get moving here. Okay, so as you're up on top, you have more potential energy. Oh dear, hang on. You have more potential energy than as if you could freeze it for a second, then you have half the potential energy right here. And then it's going to keep on going up for potential energy the higher that you are. I don't know why that keeps on doing that, but the higher that you are, the more potential energy that there will be. The kinetic energy all has to do with speed. Okay, so now you're gaining speed, and hey, there you got more potential energy. And so it keeps on going back and forth. Now, I want you to look at something else. TME, total mechanical energy. That will always equal what those two equal. I wish I could stop that thing where it is. But the whole idea of it, Okay, if you could go look back at this one more time, the kinetic energy and the potential energy switch back and forth, and they always equal this total amount here. Okay, we're moving on to the next one. I think that this is a great demonstration showing how kinetic energy and potential energy can, as you take from one, you give to the other, and so that you have the complete same amount of total mechanical energy for all of it. Here we go. So at the bottom, before you go and shoot a basketball up and then down, okay, at this very tip top part, you know it's going to have maximum potential energy. And so down here at the bottom, when you're shooting that ball up, it's going to have maximum amount of kinetic energy because that's what's going to be going as fast as. In fact, think about this for a second. So the kinetic energy is at the greatest when it's going the fastest. Now it's going to slow down as it goes up, and then it's going to come back down. Anyways, when you look at this whole part of it is slowing down, that's going to make you have less kinetic energy. Well, where is that kinetic energy? Because the total kinetic energy is potential and kinetic. So it's increasing its potential energy. So sometimes it's kind of thinking like, well, if I had a snapshot right here, how much potential energy would it have? Well, it would have about 3/4 of the maximum height. Here it'd have about half. And here it wouldn't have any because it would be at the bottom. This is just a mirror image of it so that you're decreasing in your potential energy and gaining in kinetic energy as you go along here until you're reaching that maximum speed right here for the maximum kinetic energy. So sometimes it's good to think of it as that they're trading off and switching back and forth all the time. Okay, let's look at another way of looking at this. Is it kinetic energy or is it one of the other potential energies that we've got there? Okay, so a leaf hanging in a tree. It's just hanging there. It's got potential energy. When I have examples like this, and we're not talking about switching back and forth to kinetic and potential energy, we're just talking about what is this situation for that precise second, what's happening. Nothing's moving here, so it's telling you that it is potential energy. Which ones? The one that's hanging, the one that's up high. Okay, a leaf falling from a tree. Now it's moving. Got kinetic energy. An acorn for a squirrel. Sounds like his food, so that would be chemical. Okay. Pulling back a rock in a slingshot. Okay, so you're pulling it back. So as you're pulling it, and it's in motion, if it's going backwards towards you, then it's going to be kinetic. But if you're holding it, pulling it back and holding it while you're pulling back on it, then it's going to be elastic potential. So I don't know which I was specifically asking for right there, but I think that it's saying pulling back and not holding it yet, or maybe pulling back and holding, because when you're holding it back in the ready to fly position, you're still pulling on it. So on a test, I would definitely have to be much more specific about that. A DVD playing, okay, it's spinning, it's moving, it's kinetic. Electricity on in a lamp. Sounds like electrical energy to me too, doesn't it? But that's talking more about the forms in our book. And so when you're talking about this, electricity is on, that means electrons are moving inside of the copper wires, and so it is kinetic. Soda pop. Not great energy, but you do get some chemical potential energy out of that. Shaking a soda pop. Oh, it's moving. So it is kinetic. And then I'm thinking like, okay, so you shake it up and then you're going to trick somebody and you're going to say, here's a pop, and then when they open it up, oh gosh. So see, it has a lot of potential energy until when it's opened up, then, Okay, so then the next one we have here is winding a clock with a turn key. My mom and dad have one of those old kind of clocks where you can turn the turn key and it tightens up a spring in the inside of it, and so it keeps it going for like a full couple of days. Okay, so kinetic energy, gravitational potential energy, chemical potential energy, and elastic potential energy. These are the different types of energy. And next time we will talk about different forms of energy. That's all I got for you. Over and out.